Hi, so good morning. My name is Tyler Eck. And my student number is 410-821-337, and I'm going to be explaining the assignment number 2. So I'm using VirtualBox to do it, virtual machine, sorry. And I'm using Ubuntu 20.04 to run it, which is Linux based. So I'm using those commands to run on terminal. And so this is my code. So I'm going to explain it right now. So I have a max, which is the last 8 digits of my student ID, and I have these different variables. They're average turnaround time, which keeps track of the turnaround time, the turn time, which is the turnaround time for each one, total time, the wait time, and the run time, again for each thread. And there are 5 threads, and yeah, so basically the way my code runs is that it runs through a big for loop that has 2 possible combinations. Now, to make things simpler, in my opinion, I think first in first out is a lot simpler. So that's why I use the 2 contention scopes, but first in first out for each one of them. And so I initially set all of them to 0, the variables. And what happens is we create them, and depending on the depending on the J, we set the contention scope and we set the scheduling policy. So what happens is that I never use get scope because I'm not really getting it. I'm just setting it based on this particular J value. And then I set each one, the scheduling policy and the scope. And then I get the time that it was created, which is this. And then I run each thread in the runner, and I get the time of day. Now this is where all the calculations are. It's basically total time, which is the time it was created. The time that it finished minus the time that it was created is total time. So that's this variable right here. And what happens is wait time is the total time minus the run time. Means that that's the amount of time it had to wait from the moment it was created to when it actually started to run, which is actually up here. The run time is actually up here, which is the time it takes to run. And so I minus that to get the wait time. And so I print that out, and then the turnaround time is the wait time plus the run time. So that's the turnaround time for each one of them. And so I output that, and then I add it to the average, so that in the end, after all of them run, I take the average turnaround time and I divide it by 5. And that's the average turnaround time. And in the runner, I basically do the same thing as what was given in the homework, but the only difference is that the max obviously differs for each person based on our student ID. And I guess this simulates the job that the thread does, and it does that by using for loops to run to it to basically go through time. And then I output the execution time, and the run time is going to equal to basically the execution time. So that's what holds that value up here to do all our calculations down here. So just to save time, I actually ran it already. I used these commands where you go into the file and then you run it with pthread library, and then /a.out, which gives the output. So if you see for the first one, process contention scope, first 5 values are created. And all these spaces are basically the process is doing its work. And so the spacing is kind of off, but the point is the first process starts and the total time is 42. So it runs 42, and it has to wait 0 because it's the first time that it goes in. And so the turnaround time will be 42. And then the total time for the second one will be 44, but the wait time is going to be 42 because it has to wait till this finishes. And so, yeah, as we go on through it, we notice that it shows a trend that each thread is created, because it's so fast, each thread is created at the 0th second. So all of them are basically created. One is created a little bit before the other, but they're all created around the same time, which is 0 seconds. So we find that the average turnaround time is all the turnaround times added together, which is 130. Now remember, this is process contention scope, which is the threads have to fight within to run within the or not fight, sorry. The processes run based on order, on first in first out, but the thing is it's within the processes threads. So it doesn't have to so that's the difference between process and system, because with system contention scope, which is shown right here, you'll see I will predict that the turnaround time will be a lot greater because it'll have to fight against other ones in the whole system, not just within the process itself. So as you see, it's about the same thing, but the average turnaround time would be 138. So I think that's a little bit expected. It would be a lot longer. So the process contingent scope would give a better turnaround time, average turnaround time. But yeah, that's my code right there. Cool.